Hello, my dear students. I am your new physics teacher. From today on, we are going to study about your courses in physics that are mostly focused on JEE Mains. And so every day I will come up with some questions from your previous year question papers of JEE. So today we are going to discuss two questions on atomic physics. Those are related to the distance of closest approach. Let's see, in the alpha ray scattering experiment, if this is the nucleus and let's say an alpha particle is approaching to this nucleus with some amount of energy, let's say E, or which is at first entirely kinetic in nature, and this alpha particle when approaches towards the nucleus, in some situations it either gets deflected with certain angle, and in a very rare case, that is for every 1 in a 10,000 of alpha particles, they would deflect back by an 180-degree angle, that is they'll retrace their very own path. So in this particular scenario, the distance to which they go near to the nucleus, that distance is known as the distance of closest approach. Now let's see how we could derive this distance of closest approach. If half mv square is the initial kinetic energy that the alpha particle carries, and by the end of its path where it closely approaches the nucleus, its entire kinetic energy gets converted into potential energy. Which kind of potential energy? The electrostatic potential energy, whose value is given by K into charge of the nucleus multiplied by charge of the alpha particle divided by this distance. This particular distance R0 is known as the distance of closest approach. So from this you can find the value of R0 by substituting the values of all other quantities. Now let's go to the two questions that we have here. The first question says that an alpha particle of energy 5 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. The distance of closest approach is of the order of. So to find the value of R0 here, first we need to substitute the values given here. The value of half mv square is given as 5 electron volts. K, whose value we already know, which is 9 into 10 to the power 9. Z for uranium is 92. E is the value of charge of electron, and then comes R0. And now substituting the values of all these quantities, we get the value of distance of closest approach as 5.29 into 10 to the power minus 14 meters. But see, here our options are given in centimeter units. So when converted into centimeter, we find the value is 5.29 into 10 to the power minus 12 centimeter. So our correct option will be option C. Note this. Now coming to our second question. This question says that an alpha nucleus of energy half mv square bombards a heavy nuclear target of charge Ze. Then the distance of closest approach for alpha nucleus will be proportional to what? What of the following options? Just now we have derived that the value of the distance of closest approach is found as R, which is equal to K 2Z square divided by half mv square. Okay, so from that you can see that the option which would be correct is option C, which gives the value of 1 by m, or R, which is proportional to 1 by m. So option C will be the right answer. So this is for today, my dear students. I hope you come back tomorrow for my classes. Thank you so much.